this is number 8. So 8 wants us to find the integral of x to the 7/3 minus 1 over x squared dx. So when you first see this, you want to recognize that there is only one term on the bottom. So here I just have 1x squared. So I can split it up to both of the terms on top. So just like when we did derivatives and you only have one term on the bottom, makes it easier to split it up so you don't have to use quotient rule. Well, here it makes it easier to split up because this would be a very hard integral to evaluate. So I'm going to split it up as x to the 7/3 over x squared minus 1 over x squared. Okay? And now I can make this two integrals, like the integral of x to the 7/3 over x squared minus the integral of 1 over x squared. Okay? So now you should remember that if I have the same base, I subtract, and I'm dividing, I subtract my exponents. So here I have 7/3 minus 2, which is 7/3 minus 6/3, which is 1/3. Okay? So I'm just going to rewrite it as x to the 1/3 minus integral of x to the minus 2. So I just brought it up. So now this should be familiar. When I take the integral of x raised to a power, that's a number, I add 1 to that number and then I divide. Okay? So this would be, I add 1. Okay? So it would be x to the 4/3, then I divide by 4/3. And then here, so I'm sorry, it's minus, and this would be, use some parentheses. When I add 1, I get -1, so I get x to the -1 divided by -1. Okay? So I add 1 to the exponent, then divide. So this is 3/4 x to the 4/3, and then this becomes a plus 1 over x, and then I always have to add my constant. Let's see there. Okay. That's your final answer, and believe that is choice D. Okay. So on this problem, the trick to it was splitting up the integral into two separate ones with x squared on the bottom because there's only one term on my bottom. And then I can subtract exponents because x is the same base and I'm dividing. So when I do that, I get x to the 1/3. Then I add 1 to the exponent and divide by that number. I flip my fraction, and that's my answer. So that's number 8.